The telescope would also help answer another one of the most profound mysteries ever contemplated. How old is the universe?
The Hubble Space Telescope represents exploring in the true sense. You don't know what you're going to find.
The discovery of the age of the universe would take a circuitous route, building on Edwin Hubble's breakthrough that showed the universe is expanding. It would also set the stage for a shocking surprise.
Everybody had known for many years that the universe was expanding, but everybody had assumed that the universe would slow down in that expansion because gravity would attract everything to everything else, and that would slow the expansion. And the big question was, is there enough stuff in the universe to gravitationally attract the universe to come to a halt?
Is gravity retarding it enough that eventually the expansion will stop, and then the universe would start contracting? And so we wanted to measure, as far out as we could, as far back in time as we could, the past expansion rate of the universe and compare that to today.
Like Edwin Hubble had decades before, the scientists needed to find stars of known brightness so they could accurately measure distances. Hubble had used Cepheid variables, but Perlmutter and Reese searched for something called a supernova type 1a. These exploding stars all burn with the same peak brightness, 5 billion times brighter than our sun. But the trick was to find them.
They really are rare. They only explode a couple times per millennium in a given galaxy of 100 billion stars. And for that matter, they don't give you any advance warning. You don't know when it's going to happen. And then once a supernova explodes, it brightens in a few weeks and it's faded away in a few months. But if you can observe some, 50,000 galaxies in the course of a night, and then if you can wait a few weeks and come back and observe the same 50,000 galaxies, now you have a reasonably good odds that new supernova will have exploded in some of those galaxies.
The Hubble images made it possible to measure how far away the supernovae were and how long it took their light to reach the Earth, even when they had exploded billions of years in the past.
And that's, of course, the whole game here, because you need to be able to tell the brightness of that supernova to tell exactly what point in time in history you're looking at.
With the same technique Edwin Hubble had used, redshift, Perlmutter measured a distant supernova's light to see how fast it seemed to be moving away. He expected to see that the expansion of the universe was slowing down, but he was in for a surprise.
It was 7-8 billion years back in the past, and that one supernova suggested that the universe was not slowing down. And this was very interesting, very puzzling.
His team then analyzed 42 more supernovae and came to a shocking conclusion.
That data set strongly suggested that the universe was actually speeding up.
Adam Reese was part of a competing group, and his work was yielding the same odd result. Looking into the past, he expected to see that the expansion of the universe had slowed, but 5 billion years ago, it started to accelerate.
You know, you worry a tremendous amount because there are many ways to get a measurement like that wrong. Pretty much only one way to get it right.
The two teams working on this at this point were in really tight rivalry. We were not talking to each other about what we were finding at all.
You wake up at 2 in the morning and you think, oh my God, did I account for some subtlety?
We knew that if we got anything wrong, the other group would be sure to point it out.
Did I subtract it from the total? Is this right? And, you know, this is like cosmic accounting. You know, you got to make sure that it's right.
But the numbers were correct. Within weeks of each other in 1998, the two teams announced the same shocking conclusion. The expansion of the universe was speeding up.
You have been awarded the Nobel Prize in Physics for the discovery of the accelerating expansion of the universe.
Perlmutter and Reese, together with Reese's team leader, Brian Schmidt, shared the 2011 Nobel Prize in Physics. But their discovery had opened up a whole new mystery. What was fueling the acceleration? Scientists called it dark energy.
Something like 70% of all the stuff of the universe has to be made of this dark energy for the universe to be accelerating the way it is. And so it's possibly the most important stuff in the universe, and we don't know anything about it.
I don't really know what dark energy is. We don't have an explanation that would satisfy really anybody, especially a physicist. And so it's blowing everybody's minds again. I mean, physicists call this the most important problem in physics because we don't know where this dark energy's come from. We can't calculate where it's come from. Our models don't work.
But despite the mystery, the discovery helped finally resolve the question astronomers had dreamed of answering for centuries. How old is the universe?
You need to know that history of when was it faster, when was it slower, if you're going to piece it all together and working our way back to the point at which all the distances would go to zero, the beginning of the universe, the Big Bang.
Scientists found Cepheids and supernovae stretching far across the universe. They used Hubble to measure their distances and redshift to figure out how fast these points seemed to be traveling away. This revealed how long the total expansion had taken since the Big Bang.
Hubble provided a ruler for the universe. So when you put together the basic size and the history of how fast things were going in the past, you get 13.7 billion years.
Our universe is 13.7 billion years old. Hubble had finally helped answer this fundamental question.
There was a promise, and Hubble delivered on that promise.
And then, nearly a century after Edwin Hubble first glimpsed galaxies beyond our own, the Space Telescope took on another profound question. How do galaxies actually form? At the center of the mystery, black holes. Regions so dense that nothing can escape their pull.
The basic idea of a black hole is the gravity is so strong that nothing can escape. Even lights cannot get out. We can't take a picture of a black hole directly. It's black. So how do we know it's there? We know it's there by studying the way stuff moves in its vicinity. Things orbiting close to it are going to go very fast. But you have to get very close to the hole in order to see that effect.
Scientists had theorized, but never proven, the existence of supermassive black holes billions of times the mass of our sun, until they used Hubble to look at the core of a galaxy called M87.
It was the superior spatial resolution of Hubble that was the key. In the galaxy M87, the gas on this side is coming towards you, and the gas on that side is going away from you. And we can measure the motions and calculate the mass of the black hole 3 billion times the mass of our sun.
But how common are these giant black holes? Sandra Faber's team used Hubble to measure the speeds of stars orbiting around the center of other galaxies and discovered something remarkable.
We accumulated measurements of stellar speeds in, I would say, 24 galaxies. And in every one, we found evidence for a compact central mass.
Essentially, at the center of almost every galaxy, there is a supermassive black hole. There is some regulating mechanism here that makes the black hole and the bulge of stars around it grow together. So it is a chicken and egg problem in the sense that did the galaxy form first and then a black hole grew inside it, or did the black hole kind of seed the formation of the galaxy? And we're actually not sure what the answer to that is.
The precise relationship between supermassive black holes and galaxies remains a mystery. It's just one of the countless questions and profound discoveries generated by Hubble over its 25-year history. And its continued success is a testament to the humans who have kept it going.
We want you to use your best judgment that the pitching array will definitely clear the top of HST.
Astronauts have upgraded the telescope on 5 different missions since its launch.
Hubble has arrived on board Atlantis. Okay, here we go.
The last visit to Hubble was in 2009. Astronauts needed to replace the wide-field camera and install and repair spectrographs that could help peer into black holes and analyze the atmospheres of distant planets. As on past missions, ingenuity saves the day.
That handrail is obstructing the attachment of the fastener capture plate.
Astronaut Mike Massimino can't remove a handrail blocking his access to Hubble.
We couldn't get inside the thing to do the repair. And I just felt terrible. This is going to be my contribution to astronomy, which is killing our opportunity to be able to analyze the atmospheres of planets.
That darn handrail.
And I thought we were sunk, because I did not see any way we were going to fix this thing.
And then engineers come up with a radical idea. Break off the handle. It's a risky approach.
By yanking that thing off, by definition, we're going to have little shards of metal flying. So I put a lot of tape on that handrail to make sure that, you know, none of that stuff would get out.
Houston, you ready for this? Yeah, we're ready.
Okay, Mass, you have a go.
Here we go. Disposal bag, please.
The handrail was out of the way. It wasn't going to be a problem anymore. I felt really happy that we got the job done and that we were leaving Hubble in good shape.
Hubble is working right now, probably the best it has ever worked. It produces discoveries every day.
The new instruments have allowed us to look deeper into the universe, revealing even more detail than before. This recent image of the Andromeda Galaxy is the highest resolution Hubble photo ever taken. More than 60,000 light-years across, it shows more than 100 million stars. And just this past year, a spectrograph installed on Massimino's mission analyzed the light filtering through the atmosphere of a planet 729 trillion miles from our own, and found water.
We absolutely couldn't have done this work without Hubble.
It's a remarkable contribution for a 25-year-old machine.
Every one of the science instruments were eventually replaced. You don't have any of the original ones left. And that's why it's still doing its job 25 years later. We don't warranty the labor. I'm not sure about the parts. You got to check with NASA. But I think it's going to be going for a long time.
But with the space shuttle decommissioned in 2011, there's no way to reach Hubble. And the telescope's days are numbered.
And John, this is like spacewalk number 714? Six. Okay, great.
Astronaut John Grunsfeld visited Hubble 3 times, more than anyone else,
Ready, John.
and was the last human to touch the telescope in 2009.
We'd finished all of the work that we had planned, and I was in my spacesuit, getting ready to come back into the airlock, and gave Hubble, one last tap to say goodbye. And I just felt incredibly happy that we'd had this amazing ride. I watched it disappear off into the distance, and I knew I would never see Hubble again. But we'd accomplished so much; it was just a matter of joy.
Scientists hope that Hubble will work for another decade. But with every orbit, it encounters slight drag from the Earth's atmosphere. The telescope will eventually fall from the sky, probably in the late 2030s. Most of Hubble will burn up, but the mirror will likely survive re-entry. So NASA may send up a robot with a small rocket to help guide it safely into the ocean.
One of the requirements for the mission that we flew in 2009 was to install an adapter on the bottom of the Hubble Space Telescope so that a future mission could dock with it, so that at the end of Hubble's life, we could send it into the atmosphere so that it would re-enter over a known place.
But before Hubble deorbits, NASA is planning to launch an even larger telescope called the James Webb. It has a foldable mirror 3 times larger than Hubble's and will be sent to an orbit beyond the moon. But it will be hard to live up to the legacy of Hubble.
The Hubble Space Telescope is probably the most scientifically productive instrument in history. Before the Hubble was launched, we didn't actually know the age of the universe. The Hubble just sorted that question out, bang. We had never seen black holes before. After Hubble, we know that every single galaxy has a black hole. We knew that when stars finish their life scale, they form planetary nebulae. Hubble just cataloged every single type of planetary nebulae, and then it caught supernova, blowing up. We had no idea the universe was filled with dark energy. We didn't even know that was possible. We've seen into the depths where stars are formed. We can actually see the formation of planetary systems. We knew that theoretically. We can now see all of that stuff. Just tick off all of those discoveries, and our whole worldview has just changed.
The human desire is to find out who we are. Are we alone? Where did we come from? How did we get here? These questions probably will outlive all of us. But I think Hubble has been very important in making progress toward these answers.